Chapter 7. From the Depths, the Geology of Salt Formation. 1. Sir Isaac Newton's chaos, early geological theories. In the late 1600s, the smartest minds in Europe were asking a question no one had dared to ask before. How did the Earth become the Earth? Sir Isaac Newton, the man who had mapped the laws of gravity, turned his attention to the ground beneath his feet, and what he proposed was startling. In the beginning, the Earth was chaos, not rock, not land, not anything solid. A vast, churning, liquid mass, everything mixed together, minerals, water, salt, all of it swirling in a primordial soup with no shape and no order. And then, slowly, gravity took hold. The heavier things began to sink, the lighter things began to rise. Layer by layer, the chaos sorted itself. But Newton noticed something that others had missed. Salt was not just a passenger in this process. It was the glue. Newton believed that salt was the substance that allowed the crust to form in the first place. Without it, the heavier minerals would have stayed loose, unbound. The solid ground we stand on today might never have existed. The great blocks of rock salt buried deep underground, Newton saw them as the frozen evidence of that moment, the exact instant when chaos became order. This was a radical idea. Before Newton, most people believed the Earth was shaped by one single event, a great flood, a divine act, one moment that explained everything. Newton looked for something different. He looked for laws, for chemistry, for the slow mechanical forces that built a planet over time. Salt, in his mind, was the first chapter of that story. 2. Volcanic agency, sublimation from the Earth's vents. Not everyone agreed with Newton. A rival theory was gathering force, and it painted a very different picture of where salt came from. What if salt was not born from water? What if it was born from fire? The idea had a name, volcanic agency, and its supporters pointed to one place above all others to make their case: the volcanoes of Italy, Mount Etna, Vesuvius, active, breathing, furious mountains, smoke pouring from their craters in thick, sulfurous clouds, and on the rim of those craters, something extraordinary: white salt, forming directly from the volcanic gases, crystallizing out of the smoke as it cooled against the rock. The theorists seized on this. If salt could form from volcanic fumes here, on the surface, then why not deep underground? They argued that the great salt mountains of the Andes, the deep veins of the Alps, all of it pushed upward from the Earth's core, carried on rivers of heat and pressure through cracks in the bedrock. In their vision, the Earth was a furnace, a vast, pressurized cauldron buried in its own belly, and salt was the smoke that escaped. The image was powerful, almost mythical: a living planet, breathing salt out of its own fire. It explained something that other theories could not: why salt appeared in places far from any ocean, high in the mountains, deep in the desert, hundreds of miles from the nearest sea. If salt rose from below, it could appear anywhere. Later science would prove this theory wrong. Salt, it turned out, was almost always born from water, not fire. But for a moment in history, the idea that salt was forged in the planet's belly captured the imagination of an entire generation. 3. The mystery of the stratified beds, gypsum, and organic remains. As scientists looked closely at the salt deposits, the volcanic theory began to crack. Because what they found inside the mines told a very different story. Open up a great salt mine, step inside, and look at the walls. Salt was not found in random, chaotic lumps, not the way you would expect something forged in fire to appear. It was layered, neat, rhythmic, precise, like the pages of a book or the rings inside a tree. Layer after layer after layer, stretching upward through the rock in orderly bands. And between the salt, something else. A pale, chalky mineral called gypsum, a softer stone that formed a floor, a foundation beneath each layer of salt. To a geologist, this pattern told an unmistakable story. The gypsum formed first, when ancient water was just beginning to dry out and concentrate. Then, as the sun pulled more and more moisture from the shallow basin, the salt settled on top, thicker, denser, layer upon layer. Then the water returned, and the cycle began again. Seasons, centuries, millennia, each one leaving its mark in the rock. But the greatest discovery lay deeper still. Deep inside the translucent salt crystals, miners began to find things. Fossils. Not crushed, not flattened, not destroyed by heat or pressure. Preserved, perfectly, in 3 dimensions. The delicate scales of ancient fish, the shells of creatures that had lived in a sea that no longer existed. Even the needles of prehistoric trees, blackened but intact, locked inside the crystal like insects in amber. These were not the remains of something burned, something sublimated from volcanic smoke. These were the remains of something drowned, something buried gently, slowly, in water that was growing saltier by the day. Fire would have destroyed them instantly. Only water, quiet, patient, mineral-rich water, could have preserved them like this. The stratified beds, with their fossils and their gypsum floors and their rhythmic layers, were a tomb, a time capsule, a record of an ancient sea that had slowly, over millions of years, dried itself into stone. The mystery was solved. Salt was born from water, not from fire. 4. Salt lakes, relics of ancient oceans. There are places on Earth where you can watch salt being made, right now, in real time. They are called salt lakes, and they are among the strangest landscapes on the planet. The Dead Sea, the Great Salt Lake of Utah, the shimmering flats of the Bolivian Altiplano. These are not ordinary bodies of water. They are trapped oceans. Seas that were cut off from the rest of the world by shifts in the Earth's crust millions of years ago. And since that day, they have had no way out. No river carries water away from them. No channel connects them to the sea. So the water stays, and the sun beats down. Year after year, the water evaporates, but the minerals, the salt carried down from the mountains by rivers and streams, those stay behind, concentrating, growing thicker, heavier, more potent. Some of these lakes are 10 times saltier than the ocean. The landscape is otherworldly. The water itself changes color. Deep blue in some light, blood red in others, stained by microscopic creatures that thrive in the brine. The air is so thick with salt it stings the throat. A fine white dust settles on everything, on your skin, your clothes, your eyelashes. And along the edges, where the water meets the shore, the salt does not simply settle flat. It blooms. Strange, cauliflower-shaped structures rise from the shallows. Jagged crystal formations push up from the mud like teeth. The shoreline breaks into vast, cracking patterns, polygons of dried salt stretching toward the horizon like shattered porcelain. This is what salt formation looks like before it becomes stone. These lakes are the living laboratories of geology. The same process that created the great salt beds of Europe and America millions of years ago is happening here, today. Watch long enough, and you will see the future mines being built, one crystal at a time. 5. Geological erraticism, from Galician Tertiary to New York Silurian. Here is something that should stop you in your tracks. Salt does not belong to one era of the Earth's history. It belongs to all of them. The salt beneath the mountains of Poland and the salt beneath the lakes of New York State were formed hundreds of millions of years apart, in completely different worlds, under completely different conditions. And yet, both are salt, the same mineral, the same crystal, the same white cube. Start in Poland, in the mines of Wieliczka. This salt is young, geologically speaking, formed around 13 million years ago when the mountains of Central Europe were crashing into one another, great sheets of the earth colliding, the land buckling, folding, twisting. And a piece of ancient sea trapped between the rising mountains was squeezed, compressed, forced into shapes that salt is not supposed to take. Go into these mines and you see it. The salt here is not flat, not orderly, not layered in neat rows. It is twisted, folded, contorted into wild, chaotic forms, gray and green, stained by the young, turbulent earth that shaped it. Salt born in violence. Now, travel to the other side of the world, to the deep underground deposits beneath New York State, beneath the Finger Lakes, beneath the quiet farmland of the American interior. This salt is ancient, 420 million years old, older than the dinosaurs, older than most of the life on Earth today. It was formed in a world where the first plants were only just beginning to creep onto land, where a vast, shallow tropical sea covered the heart of North America in warm, still water. And it settled, quietly, patiently, layer after layer, undisturbed for millions of years. Go underground here, and the salt is flat, horizontal, smooth, vast pancake layers stretching for miles in perfect, unbroken sheets, pale and translucent, calm as still water. Salt born in silence. Two deposits, two worlds, hundreds of millions of years apart, one twisted by fire and collision, the other laid down in stillness and peace. And both salt. This is what the Earth is telling us. Salt is not a one-time event. It is a recurring rhythm, a pattern that repeats itself again and again whenever the conditions are right, when a sea is trapped, when the sun is strong, when time is long enough. Continents drift, oceans vanish, mountains rise and fall. But the dance between water and sun, the quiet, endless making of salt, that never stops.